How much is this?
350.
Uncle, what about this?
150.
Plus 150 is equal to 1 is equal to 2 no. 350 150 400 400 more. 5 dirhams 350 150 150. Oh my god.
Math is often prejudged as a subject that is feared, complete with the stereotypical notion of extremely strict math teachers. But you know what? Math isn't that one mind-boggling subject which no one understands. Math is one of those love-hate things. Those who get the hang of it can't get enough of it, and those who didn't, well, it becomes the subject of their nightmares. One of the main reasons for this deep-rooted fear is a weak foundation during the early stages of learning. When students don't understand a concept during the early years, it leads to more confusion and misunderstanding of complex concepts in higher grades, leading to an aversion towards the subject. But maths is everywhere around us. Every time your mom goes to a store and weighs in whether a special offer is worth it or not, maths. The technologies on which all of your tablets, your phones, your computers are based, it's all maths. Maths is the basis of all the sciences. Everything from glaciers melting, to plastic surgery, to roller coaster designs, to digital music is based on maths.
$150, $350.
Will this be enough? 350, 150, 500, 500.
Okay, set, bro. Okay, set.
Things worth 500 dirhams for 5 dirhams. Wow.
A great way to give students meaningful opportunities to apply their learning and lower the effective filter is to make learning fun. So the Max department is all set to present to you the Max Month. A bunch of creative and informative competitions are on your way, so don't forget to grab these opportunities. The Max Month will be making a kickstart with digital logo and poster making. The students can make an eye-catching logo or poster on everyday Max, Maths and nature, and also on Maths and other subjects. Next, all the young mathematicians, brace yourselves for the second week of Maths Month. The students are given a chance to make videos related to math, like Vedic maths, math tricks, Rubik's Cube solving, and much more. Next, we have the virtual skit, which will be a group activity. Make a skit on any topic related to math. You need some help for ideas? Here you go. Skit about mathematicians, math-related folk tales, or skit based on real-life math. For the last event, we will be having a grand quiz on mathematics. So, brace yourselves and prepare well for the Max Month. As I told earlier, grab this opportunity and unleash your talents. Best of luck, everyone!
Sapamagata kita tadi midirana. Sapamagata kita tadi midirana. Sa rigatabari rigarini sa rigatabari. Sapamagama gapaga garisanisa garisanisa. Donde está mi ante? Say yeah yeah yeah. tadi midirana Karisa, karisa, karisa Karigasa, sa karigasa, sa karigasa C'est comme si, c'est comme ça Ma chérie, la 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 Karisa, karisa, karisa Re baba da, re baba di da C'est comme si, c'est comme ça, ma chérie, la 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 la.
name is Alish. I'm in 8th level of Abacus. Today I'm going to show a demo on Abacus and I'm learning from Brain of Brain. So now I'll show you how to set an Abacus. This is how I set an Abacus. This is ones, tens, hundreds and thousands place. This is the center point. Now I'll show you 1 to 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. Next I'll show you 10 to 90. 10, 20, 30, 40, 50, 60, 70, 80, 90. Next, I'll show you how to represent a number on Abacus. For example, 259. 2, 5, 9. Next, I'll show you addition subtraction. 7 numbers, 3 digit. 5, 8, 4. 1, 1, 6, 6, 9, 2. 2, 6, 3, less 5, 1, 2. 2, 4, 2, 3, 5, 9. 1, 7, 4, 4. The answer is 1744. Next, I will do multiplication 3 digit into 1 digit. 793 into 2. 7 into 2, 1 4. 9 into 2, 1 8. 3 into 2, 6. 1 5 8 6. Thank you.
Hello everyone, so welcome to the world of Vedic maths. So today I'll be teaching two concepts, two tricks of Vedic maths. Number one is multiply two digit numbers each other and multiply two and three digit numbers with 11. So first we'll go with the first learning objective, multiply two digit numbers each other. So this is the question 23 into 54. This is the way how we normally do 23 into 54. 4 3 is a 12, carry 1 above the 2, we write the 2 here. 4 2s are 8, plus 1 9, and we carry on. Then we finally get the answer as 1 2 4 2. This is the answer. In Vedic maths way, we do it as 23 into 54, we write it horizontally. And we multiply the 10th digit of both the numbers, which is 2 and 5. We multiply them, which is equal to 10. And we multiply 5 and 2, we get 10. And the second, we multiply the ones digit of both the numbers, which is 3 and 4, we get 12. We keep this aside and next we'll go to the next step. So the further movements will continue as the first we will multiply ones place of the second digit and 10th place of the first digit will multiply, which is 2 and 4 we multiply, which is 8, and we will multiply the ones digit of first digit, the first number, and 10th place of the second number, we multiply them, which is 3 and 5, we get 15. And now I'll explain you further with some example. So now what we do, we got four digits. Here we got 4 numbers here by multiplying both together, each number together. Now we'll take the first digit, which is 10 and 12, which is the multiplication of 2 into 5 and 3 into 2, the numbers. So we won't do anything to it, we'll just write it as a 4-digit number. We write it 10 and 12, that's it, 4-digit number. We just write it like that as it is, and we won't make any changes there. Next we will write which is 8 and 15, which is the multiplication of ones and tens digit of both the numbers each other. So we won't write it as 815, we won't just write it like that. Instead we'll add them together with sum. We will write it as we'll write the sum beside it. So 8 plus 15 is 23, we'll write the sum there. Next we will be doing with these both numbers. Now we are going to solve the problem with. So we are having 1 0 1 2 there, and now we will add this 1 0 1 2 and 23. We'll write 23, which we'll get as so we get here it as we'll add this 23 into the middle of the numbers, middle of both the numbers. We won't do it from the right to left or left to right, we'll add it in the middle. This is a 4-digit number, 1 0 1 2, and 2 3 is a 2-digit number. We'll add it in the between, which is 2 we'll add 2 with 0 and 3 with 1. We get it as 1 2, 3 plus 1 is 4, and finally 2, nothing. So we'll write it as 2. We get this is the number 1 2 4 2. Was this the number we got it before when doing the normal multiplication? See, the normal way what we do, we got 1 2 1 4 1 2 4 2. So it is very simple to do Vedic maths way than the normal way what we do. We can get the answers very easily. So now we're just going to do some examples. First one is 65 and 25. So 6 2s are, first we have to multiply the 10th place. So 6 2s are 12, and then we have to multiply the last 2 digits, ones place. So 5 into 5 is 25. We write it as it is. Plus we'll add, we'll multiply 6 and 5, which is 10th place, and the ones place 6 and 5, which is 30, and 5 into 2 is 10. 5 into 2 is 10. So plus 10. We'll make it into a bracket because we are not adding all together there. So 40. We get 40 and we'll add that here as 1, 2, 1, 2, 2, 5 plus, we'll write as 40. So how much we get? We'll get 1, 6, 2, 5. Okay? 1, 6, 2, 5. Sorry, yeah, 1, 6, 2, 5. Now we'll check is this correct or not with the help of calculator. So now we got a calculator here and we're going to type it out. 65 into 25 is equal to 1625. We got the same as 1625. So now we'll go with the further examples, which is 95 into 15. So we'll do the same way. 9 into 1 is 9 and 5 into 5 is 25 and plus 9 into 5 is 45 plus 5 into 1 is 5. So we get it as equal to 0925 plus 25, 50. We always, this is just 9 here, 9 into 1 is 9, but we write it as always 2-digit numbers because we need a 4-digit number at the end when adding to the second number. So we need 4-digit numbers so that we can place it in the middle. So we write it as 09. So we add it, we get 0925 plus 5 and 0. We get as 5 will be 5 itself, it comes down, 2 is 2 itself, but 9 and 5 is 14, so we get 1425. This will be the answer. Now we'll check with the calculator, is it right or wrong? So 95 into 15, which is equal to 1425. It is the same as the answer we got. So this is the final example. What we're going to do is 2 into 8 is 16 and 6 fours is 24 plus 2 fours are 08 plus 6 8s are 48. We add them. Next we get it as equal to 1624 plus 48 plus 8 is 56, which is equal to, plus 56, and now we'll write 1624 plus 56, which is equal to 4. We get 4 here. Here it will be 4 itself coming down. 6 plus 2 is 8 and 6 plus 5 is 11 and 1 will be carry over. We write 2 1 8 4. We'll check is this the answer or not. So 26 into 84. We are just checking it out. It is 2184. What we did was correct. So now we are going to our second topic. Multiply 2 and 3 digit numbers with 11. So this is a very simple method when doing with the help of Vedic math. So the normal way how we do 1 into 2, 2, 1 into 1, 1, 0, 1 into 2, 2 and 1 into 1, 1, 12, 1, 3, 2. This is how we do normally. But when we do in the Vedic math, it's really simple and we can do it in seconds. Like literally in 2 seconds we can do that. Just we have to do is write the 2-digit number. We have to write it one, like we have to separate the two-digit number. The first 10th place we have to write it as a first digit, and the ones place we have to write as the last digit. So we have a middle space in between. There we have to add 2 and 1, which is the two numbers. We have to add them, and we have to write it in the middle. This is how we do the multiplication of 11 with a two-digit number. So we'll go for some examples. So 26 into 1 into 11 is 2 and 6 we'll write in the between itself, and 2 plus 6 is 8. 7 and 11, there's a small confusion here. I'll say what it is. Here when we write, we are writing 7 first digit, and 5 is the last digit. In between, 7 plus 5 is equal to 12. But we can't write 7 1 2 5. That's a wrong answer. So when we get a two-digit number in the between, the number which we are finding in the between, if we get a two-digit number, what we should do is like, we should add we will write the 2 here itself and take this 1 and we'll carry over it with 7. The first digit we'll carry over it with 7, and then we'll continue. So it becomes 7 plus 1, which is 8, 2 and 5, 8, 2, 5. Got? And this third one is also the same way. We'll write 6 as the first digit and 9 as the second digit, and in between, when we get the sum, it is 15. So add 1, so it becomes 7, 5, 9. So multiplying 3-digit number with 11 is also similar to multiplying 11 with 2-digit number, but only few changes are there, but it's again very simple. So we are multiplying 1, 5, 6 into 11. So as usual, we'll write the first digit as the first place, and third digit, the last digit is the last digit itself, and in between we will write the middle digit added to the first digit. Like here it's 5, so 5 plus 1, so we'll write it as the second digit, and the third digit will be the addition of the second digit and the last digit, which means 5 plus 6, which is 11. So we get it as 16116 after addition. But we cannot write the product of 156 into 11 is 16116. It will only be a 4-digit number and not 5-digit number. Here 16116 is having 5 digits. So this is not a right answer. So there's a mistake there, that when we added 6 and 5, which was the second and the third digit, when we added, we got 11. But we should not write it as 11. We should only write it as 1-digit number. So this 11 is having the problem. So we will only write first the ones digit here, and the 10th digit will add it with the next one. So which it becomes as 1716. So we'll check this is right or wrong. So this is the answer. The final answer is this. So keep in mind that always when we get 2 digit when adding something, we have to transpose the 10th place, which number it is. We should add it, we have to carry on it to the next digit. We should not keep 2 digits together in that place. Only 1 digit at a place. So we got the answer of 156 into 11 as 1716. So we'll check is it right or wrong. We'll check 156 into 11 is equal to, it should be 1716, which is 1716. It's very easy to learn Vedic maths and do all your mathematical problems. It will make you very easy to solve all the problems and take less time to complete everything. So it is very useful for all of you.
Hello guys! What's up? My name is Haja Habib of 9B. Today I'll be explaining some Vedic tricks so that I can make your life easier. Ever been confused at looking at all those numbers? So you clicked on this video. I see. So do you know how to work on this question without spending much time on it? Eureka! Here's a solution. Better to work smart than to work hard. First, we need a quick recap on all the squares from 1 to 10. 1 square equals to 1. 2 square equals to 4. 3 square equals to 9. And by the power of floor, gang, shabam! Here are all the squares. Pretty sure we all know the squares. If you don't know the squares, please go read it up. Now, if you look closely, I have circled the ending digits. Why? Well, obviously, because they are repeating. So, these are the numbers 0, 1, 4, 5, 6, and 9. Why I wrote them like this is because 0 square ends with 0. Just like that, the rest of the numbers end with these numbers as well. So for example, it's like 0 square equals to 0, 1 square equals to 1, 2 square equals to 4, 8 square equals to 64. So 64, the ending is 4. That's why we wrote it there. Then 6 square equals to 36. See, the ending is there. And 4 square equals to 16, just like that, the same. 5 square equals to 25. 7 square equals to 49, 9. And 3 square equals to 9. So you must remember this. I repeat, you must remember this. Now, let's head on to the questions. Find the root of 15,625. Underline the last two digits. This will be our right hand side. Take the last digit of the number we underlined. What do we do with it? You guessed it! We find the square which has the last digit as 5. Now, the square is 5. 5 square equals to 25. So we should write 5 there. So this will be our first step. Since we have found the answer that we were looking for in the right hand side, let's move to the left hand side. We need to find two squares that are closest to 156. Let me see. Is it 10 square, which is 100? I don't think so. What about 11 square, which is 121? That can't be it either. What about 12 square, which is 144, and 13 square, which is 169? Yeah, these are the ones. You have to take the smallest square among these two, which is 12 square. Let's combine the LHS, which is 12, and the RHS, which is 5, and then we get the answer as 125. Mind-blowing, right? Let's do another question, shall we? Okay, so the question is to find the root of 7,569. Okay, just like we did before, we write the squares that have the ending as 9. So it's 3 square and 7 square. Since we finished doing the RHS, or else known as the right hand side, we are doing the left hand side, LHS. Find two squares that are closest to 75. So it is 9 square, which is equal to 81, and 8 square, which is equal to 64. We take the smallest, which is 64. So we take 8 square. Now we write it along with the RHS, just like how we did in the previous question. So 83 and 87 are the two answers that we got. This question is slightly different from the previous question, as the previous question had only one square, that is 5. But this question has two squares for 9. So we multiply the 9 and 8, okay, that we wrote in the previous slide. So we get 72. If the question in LHS is greater, that is 75 is greater than 72, then the answer we found in RHS will also be greater. So the answer is 87. Now that you know this, welcome to Genius Gang! Thank you for listening. Here's Hajra.
Hi everyone, my name is Joanna. I'm from 8th grade and today I'm going to show you a simple math trick. Well, not a simple math trick, it's basically how to solve a Rubik's Cube. So today I'm going to show you how to solve one side of a Rubik's Cube. So why am I going to show you how to solve one side of a Rubik's Cube? Because if you know how to solve one side of the Rubik's Cube, then it's going to be easier for you to solve the entire Rubik's Cube. So this is just a beginner's level, so let's start. So whenever you're going for any color, you have to go for the side which has the most. So I'm just going to shuffle it up. So simple shuffling. Okay. So I've just roughly shuffled it up. So I think I'm going to go for, I think I'm going to go for green. Now we have to go for the side which has the most of the green. So this side is 3, this side is 2, this side is 1, this side is 2. So we'll just go for the side which has 3. This side has 3. Now it's going to be really simple. So before you do anything, you have to see if there are any greens here. So you can just easily bring it on top. Well, I've seen and there's nothing of a green in here. So let's just, there's one green in here. Just bring it to the center. That's it. You can take this there. Because whenever it comes to the corner or at the bottom, it's going to be a bit hard. But still it's going to be really simple. I'm going to make it simple for you. Now, we can get into action. Now you can just we've got an empty space in here and we've got one green in here. Now the two greens are here, one in here, one on the bottom. So now it's really simple. This is an empty space. Just bring it down. And now you can just bring this towards this side. Just very simple. Now we've got how many? 3 more to go. Now we've got one in here. It's again very simple this time also. Now how can you do it? If you've got one in here, you have to spin this around. Now you can easily bring this down. Now we've got one in here. This can, if we twist the second level, this is the third level, second level and the first level. If you just bring the second level towards this side, it's going to be simple. Just don't forget to bring this back. Now we've got 2 more to go. So now again we've got one in the bottom, but so that's fine. Now we've got one in here and we've got an empty space in here. So we can just bring this, just twist this. Yeah. Now just bring this below and we've got one green in here. Just twist it and bring it to top. Now how much more do we have? One more. This is going to be really simple. So whenever you do whatever on top, whatever are on the bottom will automatically come on top if you have luck. So right now I have luck. Whatever came on the bottom came on the top for me. So it's going to be really simple. Just bring this area down and this one you can easily bring it towards this side. Like this. Now see, we've got a whole Rubik's Cube solved, and I'm very sure you can master a Rubik's Cube very fast. If you can, try for professional methods and go for solving the entire Rubik's Cube. And I'm really sure you can be successful in it. Just concentrate and devote. Bye-bye. Thank you for watching this video. Bye-bye. Have a nice day.
Hello guys, welcome to Mathman Show. So I'm Calvin and I'm the host of the show. I would like to invite Abhinav Shaiju, Jaden Apuraj, John Abraham, Adityan Stevery, Benjamin Chago. So in this show, I would like to ask them to speak about their favorite mathematicians and their works. So first of all, I would like to call upon John Abraham to speak about his favorite mathematician and speak about his works.
Good morning to one and all. Today I'll be talking about Srinivasa Ramanujan. Srinivasa Ramanujan was an Indian mathematician who made great and original contributions to many mathematical fields including complex analysis, number theory, infinite series and continued fractions. However, he had no formal training in mathematics when he was young. After getting his degree at Cambridge, Ramanujan did his own work. He compiled over 3,500 identities and equations in his life. His discoveries have led to many advancements in mathematics. His formulas are now being used in crystallography and string theory. After demonstrating and grasp of mathematics at a young age, Srinivasa Ramanujan began to develop his own theory from 1911. His early work focused on infinite series and integrals, which extended into the remainder of his career. G.H. Hardy convinced Ramanujan to come study with him at Cambridge. He wanted to study about continued fractions, which was unequaled by any living mathematician. The importance of his research continues to be studied and inspires mathematicians today. In 2011, Ramanujan's birthday was made an annual National Mathematics Day by Prime Minister Manmohan Singh. Unfortunately, his mathematical career was curtailed by health problems. He returned to India from Cambridge and died when he was only 32 years old. Now I'd like to pass the mic to Calvin.
Well, nice to hear from you, John Abraham. So next, I will call upon Adityan Chevri to speak about his favorite mathematician and their work.
Good morning, one and all. My favorite mathematician is Archimedes. So Archimedes of Syracuse was a Greek mathematician, physicist, engineer, inventor, and astronomer. Although few details of his life are unknown, he is regarded as one of the leading scientists in classical antiquity. Considered to be the greatest mathematician of ancient history and one of the greatest of all time. Archimedes anticipated modern calculus and analysis by applying concepts of infinitesimals and the methods of exhaustion to derive and rigorously prove a range of geometrical theorems, including the area of circle, the surface area and volume of sphere, area of an ellipse, the area under a parabola, the volume of segment of a paraboloid and revolution, the volume of segment or hyperboloid of a revolution, and the area of spiral. Archimedes died during the siege of Syracuse, where he was killed by a Roman soldier despite the orders that he should not be harmed. Cicero describes visiting the tomb of Archimedes, which was surmounted by the spear and a cylinder which Archimedes had requested be placed on his tomb to present his mathematical discoveries. Unlike his inventions, the mathematical writings of Archimedes were very little known in antiquity. Mathematicians from Alexandria read and quoted him, but the first comprehensive compilation was not made until 530 AD by Isidore of Miletus by Byzantine Catastrophe, while commentaries on the works of Archimedes written by Eutychus in 6th century AD opened them to wider readership for the first time. Archimedes was born in 287 BC and as well as he died in 212 BC in Syracuse, Sicily, Magna Graecia. Thank you. Now I would like to pass the mic to Calvin.
Well, nice to hear from you, Adityan Chevri. Nice words also. So first, next, I'm gonna call upon Abhinav Eratu to speak about his favorite mathematician and their books.
Thank you, Calvin. So today I'm going to talk about my favorite mathematician, David Hilbert. David Hilbert was a German-born mathematician. He was born in 23 January 1862. He was the most influential and universal mathematician of the 19th and the early 20th century. Hilbert discovered and developed a broader range of fundamental ideas in many areas, including commutative algebra, calculus of variations, algebraic number theory, the foundation of geometry, and so on, and the foundation of mathematics. Thank you. And thank you.
Well, nice to hear from you, Abhinav. And next, I'm gonna call upon Jaden Appu to speak about his math machine and his works.
Hi everyone, yes, this is Jaden Napuyat, and today my favorite mathematician is Satyendranath Bose. Satyendranath Bose, 1st January 1894 to 4th February 1974, was an Indian mathematician and physicist specializing in theoretical physics. He is best known for his work on quantum mechanics in the early 1920s, collaboration with Albert Einstein in developing the foundation for Bose-Einstein condenser. Fellow of the Royal Society, he was awarded India's second highest student award, the Padma in 1954 by the Government of India. The glass particle that obey Bose-Einstein statistics was named after Bose by Paul Dirac. A polymath, he had a wide range of interests in varied fields, including physics, mathematics, chemistry, biology, mineralogy, philosophy, arts, literature, and music. He served on many research and development committees in sovereign India. Bosons, a class of elementary subatomic particles in particle physics, were named after Satyendra Nath Bose to commemorate his contributions to science. Although 7 Nobel Prizes were awarded for research related to Satyendra Nath Bose concepts of the Bose-Einstein statistics and Bose-Einstein condensate, Bose himself was not awarded a Nobel Prize.
Calvin, you are muted.
Well, nice to hear from you, Jaden Apuraj. Now, I would like to ask Benjamin Charco to speak about his favorite math machine and his works.
Good afternoon, everyone. My name is Benjamin, and I'm going to talk about Euclid. Euclid of Alexandria lived around 300 BCE and systematized ancient Greek and Near Eastern mathematics and geometry. He wrote the Elements, the most widely used mathematics and geometry textbook in history. Likewise, much of Western mathematics has been a series of footnotes to Euclid, either developing his ideas or challenging them. Almost nothing is known of Euclid's life. Around 300 BCE, he ran his own school in Alexandria, Egypt. We do not know the years or places of his birth and death. He seems to have written a dozen or so books, most of which are now lost. About half of Euclid's works are lost. We only know about them because other ancient writers refer to them. Euclid's works that still exist are the Elements, Data, Division of Figures, Phenomena, and Optics. From ancient times to the late 19th century CE, people considered the Elements as a perfect example of correct reasoning. More than 1,000 editions have been published, making it one of the most popular books after the Bible. Now I would like to pass on the mic to Calvin.
So, thank you, guest, for coming to our show. And audience also, thank you for watching our show. Hope you understood every who all said and explained about their favorite math machines and their works. And thank you. Have a nice day. Bye bye.
The 11 rule. This is a quick way to multiply two-digit numbers by 11 in your mind. First step, separate the two digits in your mind. Second step, add the two digits together. Third step, place the number from step 2 between the two digits. If the number from step 2 is greater than 9, put the ones digit in the space and carry the tens digit. Examples: 72 into 11, 792. One more example: 57 into 11, it's 5 dash 7, but 5 plus 7 is 12. So put 2 in the space and add 1 to the 5 to get 627. So 57 into 11, so we will put 57, and between 57 we will put 2 because 5 plus 7 is 12, so that one's digit will be between 5 and 7. Then we will add 1 to 5, that gives us 6, so together we will say 627.
Hi, I am Isaac John. Today I am going to talk about Hardy Ramanujan number 1729. First of all, let's see who is Hardy and who is Ramanujan. G.H. Hardy is a British mathematician and Srinivas Ramanujan is known as a man who knows infinity. He is another mathematician. Once when Hardy came to visit Ramanujan at the hospital, he mentioned to him that he came in a taxi with the number 1729. Then Ramanujan said, "It is the Hardy Ramanujan number, as it is the smallest number which can be expressed as the sum of two different cubes in two different ways. 1729 is equal to 1 raised to 3 plus 12 raised to 3. It is also equal to 9 raised to 3 plus 10 raised to 3. 1 plus 7 plus 2 plus 9 is equal to 19 into 91 is equal to 1729. I hope it was interesting to you all. Thank you.
The 11 times 11 trick. The 11 times 11 trick is a simple trick that you can show to your friends. Here's how it works. Let's take 11. 11 times 11 or 11 square. We're gonna get 1, 2, 1. Now let's take 111 times 111. We're gonna get 1, 2, 3, 2, 1. Now let's take 1111. We're going to get 1, 2, 3, 4, 3, 2, 1. So let's put the theorem. There are two digits in them. So we will count up to 2. 1, 2. Then we count downwards. 1. In the case of 111, there are 3 digits. So we count up to 3. 1, 2, 3, 2, 1. In the next digit, there are 4 digits. 1, so we count up to 4. 1, 2, 3, 4. Then we count downwards. 3, 2, 1. So let's put one more number in. Let's take 1,100. 11,111 times 11,111 is equal to 1, 2, 3, 4, 5, 4, 3, 2, 1. Thank you.
Yes, I'm Sanjam. It's like I'm going to record the video of my Vedic maths. So I'm going to show you one easy trick like to multiply like things by 5. So this is one of the Vedic trick. It's Vedic trick. So this is like multiply by 5. So like when we multiply 5, if the number is like even, for example I will give like 2464 into 5. So like for that step 1, what we have to do is like we have to like divide like the number by 2. So that is 1232. The step 2 is like we have to add like 0. So it will be 12320. So therefore the answer is 12320. For checking I'll just do like 2464 multiplied by 5. So that will be 4 5s are 20, 6 5s are 30, 32, 5 4s are 20, 23, and 5 2s are 10. Same answer. So the next one, if the number is odd, then we have to like for example I will give the number as 3775 into 5. So first like we have to like do is like we have to look step 1. We have to do is like we have to like subtract 3775 by -1 as it's an odd number. So I'll be getting 3774 and 3774. Like then I have to divide it by 2. So I'll be like getting 1887. Then then step 2, as it's like an odd number, I will not add 0, I will add 5 plus 5. So it will be 18875. That's the answer. Like if you want to check out like for like checking if it's correct, we have to like do like 3775 into 5. So it will be 5 5s are 25, 7 5s are 35, 36 37, 7 5s are 35, 36 38, then 5 3s are 15, 16 17 18, and that the answer is same. So here I prove like these are the two like one Vedic matrix I did. Like this is one of the Vedic matrix. We have to multiply by 5. This is an easy trick. So like we can multiply it very easily. Thank you and have a nice day.
Hello everyone, my name is Naji. I'm studying in 9A. So today I'm going to talk about a Vedic maths trick, that is calendar. So suppose your friend asks when was Independence Day was celebrated. So when was it celebrated, and he asked on which day was Independence Day celebrated. Now I'm going to say you a trick with only 7 steps without using the calendar in your phone. You could just calculate it with only 7 steps. So I'm going to say, so first the thing is that we should consider which day he's telling, like our friend is telling. So suppose it's like Independence Day, so it will become 15 in this year 2020 Independence Day. So 15 August 2020. Now the first thing is that we should do this we should convert this date into the mathematical form. So 15 and August is the 8th month and 2020. So there are mainly 7 steps I told you. So this is the first, the one thing, and the first step now, we are starting from first. The first step now is to consider the last 2 digits of the year which you have taken. So here it's 2020 and the last 2 digits are 20. So just consider that 20. Don't do anything, just consider that. Then the second one is to divide the last 2 digits of the year that you have taken by 4. Okay, so divide this last two digits of the year by 4. So 20 divided by 4. So 4 5s are 20 and you can get here 0. Now consider the quotient here, that's 5. Now you don't know like why you took only 5. Now you can understand in the fourth step, that is the coming step, that you will understand. So third one, just consider the quotient over here. Okay, just consider all of that. And the third one is to consider the first two digits. The first two digits of the year, that is also called as the century part. We should divide it by 4, and the remainder that we are getting, we should multiply it by 5. Okay, so the first two digits over here, 20 of the year, that's 20. First we should divide it by 4. So first we will divide 4 5s are 20. That you got over here 0 0. And we should not like this, like we should multiply the remainder, not the quotient. I'm reminding you, not the quotient, but the remainder we should multiply it by 5. So 0 into 5, that is obviously 0. Okay, so the remainder after division should be multiplied by 5. By 5. Okay, so the remainder after the division should be multiplied by 5. So here the remainder is 0, so it will be multiplied into 5 and you will get 0. Now the fourth step, now I'll say you what all this will be used for. So the fourth step is to add this number that we have got in the first, that is the first we consider the last two digits of the year, that is 20, and leave it there. And the second we took the 5 over here after dividing the last two digits of the year divided by 4, and we took the quotient. And the third one we took here the first two digits of the year, that is also known as the century part, and we divided it by 4 and we got the remainder, and that remainder should be multiplied into 5. So then we will add all these like 25 and 0 and plus the main the adding step is here, and you should add the date that we have taken. So 15th is the date that we have taken. So 20 plus 5 plus 0 plus 15, and that you will get 40. Okay, so we added all this and we got 40. Okay, so the next one we all added this one. So 20 plus 5, the quotient we have got after dividing the last two digits of the year by 4, and we wrote the quotient over here, plus 20 plus the quotient that we have got over here, plus the after dividing the first two digits of the year, that is the century part, divided by 4, and the remainder that you are getting after division, we should multiply into 0, that we should add with all this 20 plus 5 and plus the date. So I think so the fourth step is clear to you. And the fifth step is a month code. This you should memorize because this is the main part. So this you should memorize completely. So I'm going to say 0 3 3 6 1 4 6 2 5 0 3 5. So in this, each number represents a month. So 0 for January, 3 for February, 3 for March, 6 for April, 1 for May, 4 for June, 6 for July, 2 for August, 5 for September, 0 for October, 3 for November, and 5 for December. So here, now the thing is that we should now consider what month we have taken. So here we have taken August we have taken. So here I said each number represents a month. So this is January, February, March, April, May, June, July, August. So 2 is the month code of August. Then we should add the number we have got after addition or after adding all this, 40 plus the month code for the particular month that we have taken. So the step 40 plus 2, 42. So the number we have taken here after adding is all these numbers plus the month code for the particular month that we have taken. And now the seventh step. Is to divide this number that we have got by adding the number that we have got over here plus the month code for the particular month that we have taken, divided by 7. You may ask why 7? Because in a week there are 7 days. So 42 divided by 7. So it will become 6. 42. 0. Again, you should not consider. So before I'm going to explain this, I'm going to give you a day code. So there are a day code for each day. So 0 for Saturday, first for Sunday, 2 for Monday, 3 for Tuesday, 4 for Wednesday, 5 for Thursday, and 6 for Friday. So this month code and the day code, this is the day code. This you should memorize, okay? Then now I'm going to say the remainder that you got after dividing this number that you have got here 42 in the sixth step, we should divide it by 7. So we divided it and we should consider the remainder. It is 0. So now check in the day code. 0 what day it represents. So 0 here is Saturday. So we can say that August 15, 2020 is Saturday. So suppose if you're getting some other like you're putting some other day, date, and you got at last 1, it will become Sunday, and if you got the remainder in the 7th step 2, then it will become Monday, 3 for Tuesday, 4 for Wednesday, and 5 for Thursday, and 6 for Friday. So like that you can find which day was Independence Day celebrated. That you can answer without looking at the calendar. So before we learn how to do a non-leap year. So that one 2020 was a non-leap year. So what should be done? Because there is a different method to use. One single method that is different between non-leap year and leap year. Now I'm going to show you an example of the leap year and what is the month code that you should use and what is the difference between the non-leap year and the leap year. So now let us take an example of the leap year. So February 1984. Let's consider this date. So first, like before itself, first we should write in this date into mathematical form. So 1408 month. It's the 8th month February. It's second month. Sorry. Second month. 1984, right? So we wrote in mathematical form. The first step, like before itself, consider the last 2 digits of the year that we have taken. So first, like before itself, consider the last 2 digits of the year that we have taken. So it's 84. Now the second step, same as before, as for the non-leap year. For the leap year also, it applies the same for the second step also. That is, divide the last 2 digits of the year divided by 4. So 84 divided by 4. So So it will become 2, 8, 4, 1. Now take this question, like before itself we should consider this question, not the remainder. In the third step, to take the first 2 digits of the year that you have taken, that is the century part, the first 2 digits of the year that you have taken, divide it by 4, and what remainder that you are getting after the division, you should multiply it by 5. So here 19 divided by 4. So first we should divide. So 4s are 16, and here you will get 3 as a reminder. And like before itself, it applies that we should not consider the quotient into 5. We should not multiply the quotient. Instead, after division, we should multiply the remainder that you are getting into 5. So 3 into 5. The same rule as for the non-leap year. So 15. Now the fourth step that you have done is to add all these numbers like before, the last 2 digits of the year plus the last 2 digits, the division of the last 2 digits by 4, and what quotient did you get, plus the first 2 digits of the year, that is also the century part, divided by 4, and the remainder that you are getting in it, that you should add with these. So plus the date, same as it. The same as the non-leap year, as concept for non-leap year, you should consider it. So for fourth step, '84 plus 21 plus 15 plus 14. Okay. First, so then we will add this. So we will get here 14 plus 1, you are 13. So the answer is 134. So now that you got 134, now the fifth step is the main step, that is mainly different for leap year and non-leap year. For non-leap year, it was 033 614 625 035. But for the non-leap year, there is a different month code. So for that we discussed it's 033 614 625 035. But for leap year, there is a different month code. So fifth step, I should write a month code, that is 623. It's quite different. This is different. Don't get mixed up. 623 614 625 035. So put this in. So this code, like I said before, each number represents 1 month. So 6 for January, 2 for February, 3 for March, 6 for April, 1 for May, 4 for June, 6 for July, 2 for August, 5 for September, 0 for October, 3 for November, and 5 for December. So now here we should now consider the month that you have taken. So the month that you have taken is February. So January is 6, February is 2. Got here? So the February, now the month code is 2. Now same as like what you have got in the fourth step, we should add 134 that we have got in the fourth step, the sum of all these numbers, plus the month code for the particular month that you have taken. So the sixth step is to add the addition of all these numbers that you have got, the sum of them, plus the month code. So for February, the month code is 2. So 134 plus 2, that is 136. Okay. Okay, now the seventh step. Only this is the difference between the between non-leap year and the leap year. Only the month code. This you should memorize for leap year and what is the code, and for non-leap year what is the code. Once again I will tell you for the non-leap year. For the non-leap year it is 033 614 625 035, whereas for leap year it is 623 614 625 035. So, and now in the seventh step, like I have said before, this number that you have got after the addition of the fourth step of the addition of all these numbers plus the month code, and that, so it will become 6, so 136. So 136 divided by 7. You may ask again why 7, because in a week there are 7 days. So 7. So 136 divided by 7. So 136 divided by 7. So 7 ones are 7. So here we will get 6. Brought down to 6. 7 nines are 63. And the remainder is 3. So for this, before considering that, so the remainder of what we get in the seventh step will be the day. So I will give you the day code is same for everything. So once again I will write day code 0 for Saturday, 1 for Sunday, 2 for Monday, 3 for Tuesday, 4 for Wednesday, 5 for Thursday, and 6 for Friday. So this is the day code. Now after knowing this day code or writing this day code, we should check what is the remainder that you have got in the seventh step. After dividing the number that you have got after the addition of 134 plus 2 plus the month code, that you have 136 divided by 7, because in a week there are 7 days. So after that, we should not, I'm reminding, we should not check the quotient over here. The remainder that you have to check over here. So remainder we have got 3. So check in the which number represents the day. So here is 3. So 0 Saturday, it's not 0 over here, so it's not going to be 0. Sunday, no, because it's not 1 over here. Monday, no, because it's not 2. But Tuesday, 3. So I think that is the day. So the 14th February 1984 was a Tuesday. It was Tuesday. So by that you can say how to calculate, like if your friends ask like when was this day celebrated, on which day, you could simply, without looking onto the calendar in your mobile phone or computer, you could just easily do it. So hope you like it and hope you use it. So thank you and have a nice day.
What is this, Parvati? You had over a month to prepare. Why did you still fail in your exams?
I'm sorry, miss. It's just that I'm not interested in the subject. A little help from you would be appreciated.
What's up, Parvati? You look so tired today. Anything you want to share, buddy?
I have done my exams in the most terrible way, and I did worst in math.
There's nothing to worry about it. If you enjoy and solve problems in math, then nothing is impossible. Concepts like differentiation explains the rate of change of movement or change of quantities like population, weather and much more. Math is a subject subconsciously hidden in people's mind. It's all about people realizing it or not. More than the subject being used as a tool, it is the form of art.
the best way to communicate using science. Math is the consequence of common sense.
Ma'am, there's an urgent need for O positive blood, so could you please arrange it as soon as possible? Thank you.
Hello Prarthana, what is your blood group?
Yes, Paru, O positive. Why? What happened?
Okay, come to NMC hospital right now, fast.
Oh, okay. Tell me, Paru, what exactly happened?
Well, I was walking through the road and I saw a girl like unconscious in the road. I hurried towards her.
What did you do next? You didn't even have a phone with you, right?
The girl was bleeding very badly and I urgently needed to call the ambulance. The road was too far for me to get a taxi. I got a phone from the girl's pocket, but it was secured with a pin. The pin was a 4-digit number and I had only 5 chances to guess the right one. There are about 10,000 possibilities and all I had was 5 chances. After 3 wrong guesses, a message popped up saying mother's birthday. I assumed that it was a hint to the passcode. I checked her ID card and I noticed that she was the same age of me. After taking various statistical data into consideration, like my mom's birthday when she got married and my birthday, I guessed for the last 2 times. Fortunately, the second try was the right one.
Parvati, amazing. As I told you that day, actually it has been settled in your mind. You actually use concepts like probability statistics to save her life. Now it's my turn to learn from you.
As I mentioned before, math is a subject subconsciously hidden in people's mind. It's about people realizing it or not.
No, 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 no. Oh, he tried it.
Rahul is a teenager studying grade 9. He hates mathematics a lot, but he acts to like it for his parents. One day at school, he was talking to his friend Arjun about him hating maths.
I hate math. Ugh, it's so frustrating.
But maths is helpful.
No. Since when was it so easy and helpful?
The teacher hears the conversation and asks his classmate to call him.
Rahul, teacher is calling you.
What happened?
I do not know why.
Rahul, why do you hate maths?
No, sir. I love mathematics.
Don't lie. I heard you say that you hate maths.
Teacher, because it's so hard and frustrating.
It is not so hard. I have a tuition. You should join.
Okay, sir. I'll inform my parents about this tuition and join, sir.
While this was going on, 3 students heard this and was having a conversation.
Did Sir say Rahul will join us?
Yeah, sir said that.
He's gonna fall in love with Max.
Rahul then joined the tuition and was surprised to see his friends.
Hello. Did sir give you an invitation?
But you hated math. Why did you join?
People who are here hated maths, but because of teacher, all began to love mathematics.
Good morning, everyone. Today, I would like to welcome a new student. His name is Rahul.
Thank you everyone for welcoming me.
As time went by, Rahul started to like maths and understood the topics very well. Then one day, teacher decided to teach a different topic.
Okay, children. Now, I would like to teach a new topic. The importance of maths. Mathematics helps us in finance, cooking, and in most of the jobs there is maths. In time management there is maths. So, mathematics is all around us.
Now I understand why maths is everywhere. Now I love maths.
Now Rahul understood why there is maths all around us and he started to love and enjoy studying maths.